Okay, I'm going to talk about contextual problems involving polynomials. So I'm going to draw a graph of temperature. So let's have intercepts of 1, 2, and 3. Okay, and it's going to cross at -12 on the y-intercept. So we see a bounce, a crossover. Okay, so this is the temperature, and this is the time. And this will be in hours. And this is in degrees Celsius. Okay, so let's describe it. So when you start, it starts to get warmer and warmer, and then it cools down a bit, and then it gets warmer, and the temperature actually goes above 0, and then it starts to drop again. So that's what's going on with the temperature. Let's make an equation. Okay, so let's go the temperature equals, we don't know the coefficient, we know the intercepts are 1 and it's a bounce, and 2 and 3. Then we know that at 0 the temperature is -12. So let's figure out the coefficient. So plug in 0 for the x, and the y value is -12, or in other words, the temperature is 0, or the time is 0, and the temperature is -12 there. Okay, so -12 equals the coefficient times -1 squared is 1. So that is 6. So A is the value of -2. Okay, so our equation, the temperature equals -2 times, we could go any variable, but let's pick x. Okay, so there is that. So estimate the temperature at 4 hours. So if I was to estimate the temperature at 4 hours, I would have -2, 4 minus 1 squared, 4 minus 2, 4 minus 3. Okay, so this is -2. This is 3 squared. So 9 times 2 times 1 equals -36 degrees Celsius. So as you can see, that if you keep going 1 more hour, all of a sudden the temperature is going to be way down there. So what can we conclude is that when you use polynomials in word problems, that often they only make sense for a very short amount of time. Obviously, especially during the end behaviors, because they go up and down so rapidly. So kind of in this zone is the biggest predictions you can make, and then from then on they don't really make sense. Okay, so some short amounts of time the polynomials apply to word problems. Okay, so looking at that, I might ask to predict the max temp. Okay, so on this case I know that it's going to be between 2 and 3, so you can approximately say at 2.5 hours. Okay, you can test different numbers if you want to get a more precise answer. So you could test like at 2.3 hours, 2.4, 2.5, 2.6. But because this is just saying to estimate, we can use approximately 2.5. So now when you plug that in, you get -2 bracket 2.5 minus 1 squared, 2.5 minus 2, and 2.5 minus 3. So calculating that, the temperature is 1.125 degrees Celsius. So that is approximately the max height. or so approximately the max temperature. Okay, next one. I'm going to give you a box. Okay, we're going to make a box by cutting the corners out of this, and we know that it's a 6 by 6 centimeter. Okay, and we're going to cut X centimeters out of the corners. Okay, so let's talk about the volume of this box that we create. Okay, can you visualize it? Cut those, fold that up. Okay, so the volume equals length times width times height. Okay, so this box would now have that as a dimension for length and width. So this would be 6 subtract 2x. And on this side, your new dimension is also 6 minus 2x. And the height of the box would be this, because you fold that up. Okay, so the height is x. Okay, or you could rewrite this 6 minus 2x squared times x. Okay, so the zeros, here your 0 is 3, and here your 0 is 0. So graphing this, okay, we know we have a bounce off of that one. Okay, so let's think about this though. Can you have anything beyond lower than 0? And that doesn't make sense, right? Because this is the dimension. So really it only makes sense starting here, this polynomial. And then at 3, right, if our x was 3, this would be 3 and this would be 3, and when you cut 3 and 3 out, it actually makes this side 0, so you can't have that as a dimension. So really, if you wanted to think about the polynomial, what it's representing, we could only include this part of it. We couldn't include the 0, we couldn't include the 3, or the parts outside of that. Okay, so if we're estimating what the max volume is, you could make a prediction at approximately 1.5 centimeters. Okay, so if I plug that in, I get 6 subtract 2 times 1.5 squared times 1.5, which is 13.5 centimeters squared. And again, that's just an estimation. If they're looking for more precise answers, you might have to test 1.4, 1.6, anything in there just to see what the pattern is. Or if you have a graphing calculator, you could actually find the max point that is in that region exactly.